Hey there, today we're going to talk about measurements and performance of the Pulse DAC Signature Edition, which is this guy right here. And Larry can put it through its paces, I think, huh?
Yeah, and you know, this is the last series of the measurement on the Pulse DAC. We measured a lot. We are done. Signature Edition. That's the last one. We are done. The best. All right, so easy. You see the WBT solder? That's what we put here in this board. Every analog thing, and including the naked resistor, the output part we will use here. And we will have more golden shiny connector from cutters and WBT when we got the chassis here. The chassis is on the way. Haven't finished yet.
Okay, so these four connectors here are going to be replaced with Cardus and WBT.
Yes, you're right. And you can see here, Devin can do an introduction.
Oh yes, this is the new matrix board for the chassis 2.0. So it has a different digital encoder. It's actually it feels a lot better, and it's a lot more responsive. As you go through the menu system, it's just a lot more responsive. And we've had some guests, some Geek Force members come back and actually come to the office and use this. We're really pleased with this. And the best part is right here. That is how you flash the firmware for the matrix board, is just through an SD card. So we'll publish firmware updates on our website. You can just load them onto an SD card, stick it in there, power cycle your unit, and it updates.
Yes.
Pretty cool.
All right, so we always look down the most important thing first, the THD, right? It's a basic, very important. So let me show you. This is the FTM mode, the femto clock mode, and femto time mode, sorry about that. And see, the THD we are talking about is 0.00066 something on both channel, well balanced, almost perfect, like a textbook. So every signature edition we will use hand match, everything is perfect. And I want to show you guys one more thing.
And that hand matching is important to get that close, right?
And yeah, make it number low. See, the bandwidth is 45K here. If we use the normal industry standard, it will be only 22K. See, that number will be even prettier. But our standard, we believe that 45K is usually what we do. But you see, 45K only increase that a little bit. Increase the benefit to 90K, which is already, how many times? 3 times, 4 times more than people can hear. Still.
So that only changed to what? 10 thousandths of a percent.
Yes. And if we want to go crazy, this machine can give you 1 mega. Want to try that?
Yeah.
Yeah. We hand match that very well. Still 0.004. Wow.
And the reason that it goes up is because noise tends to go way up into the super high frequencies, right?
Yeah, and it's THD means we will measure from 1K all the distortion to 2K, 3K, 4K, all the way to 1 mega. 1 megahertz. It's something like you cannot hear, you can see it. I don't know.
Yeah,
it's very nice.
pretty impressive.
So that's THD. For the rest of the thing, let me go back to normal 45K. We can see the crosstalk on. It's about, yeah, you can even see a bar here. Minus 130 dB. That means that fully balanced dual mono, everything got separated. You cannot get even better result. Done.
It's doing its job.
Yeah. IMD, so perfect. Should be. Double channel, you drive that with 7K and 60 Hertz on the SMPTE standard on 1:1 ratio. You can see that both are minus 110 dB.
Okay, so Larry, what that's doing is that's giving the system 2 tones, right?
Yes.
And measuring intermodulation
distortion
between
yes.
the 2 tones.
Yes.
In a perfect world, there would be no intermodulation. Theoretically, it's not really possible. So 110, 111 dB down between those 2 tones.
No complaints.
Yeah.
No complaints. You cannot complain on that. So okay, let's see something really important. I think Gavin will talk to you about that a little, but I would love to use the FFT, because that's the thing we always love to see.
Yeah, actually, this is my passion. The reason that we have let's see, frequency response mode and time coherence mode is because Larry and I like to talk theory, music theory, mathematical theory, and we're kind of nerds that way, and that's why we ended up with those two different digital modes. But one of the things that I want to show you, when you're looking at this noise floor, and
It's minus 150.
150-ish, right? So we're giving it a 1K tone, and then you can see harmonics ringing up at the harmonics, which are full integer multiples of the tone. So at 2K, 3K, 4K on up, you're seeing these ring up, and you can see it's pretty natural. It kind of slopes off and decays. But what most people think in here is just noise is actually, if we were to look between an octave, that noise is actually really important. I think I can zoom up here, right?
Yeah,
so
whatever.
maybe I go between 1 and 2.
Yes.
So we're just going to zoom up and let it find its place here for a second. What you'll find is here's the fundamental frequency, and then this is the fundamental frequency times 2. This, in nature, harmonics happen this way, and electronically as well. But the other peaks that you'll see are really interesting. You can see that what we're kind of seeing is a pattern that goes like this, right? And what's really fascinating about this stuff is these are actually hitting different intervals between the octave. Some of them are consonant, some of them are dissonant, but the intervals play a very, very important role. So you can see, if you were to mathematically figure out the ratios, if I'm just looking at it, I'm looking at probably a major second right there, and a perfect third right around in here. Perfect fifth comes up in here all the way.
Get rid of one channel.
Yeah, maybe so.
That's
Yeah, and all the way up to the major seventh, you can see all these little intervals. Many of them are super important in order for it to actually sound like music. Because when we're talking about something that performs so well, maybe with a question that people ask is, well, is it too, I don't know.
We are not machine.
Too clean, right?
Yeah, too clean, right?
Right?
It's not.
But the natural, not only harmonics, but intervals exist in the music as well. So this is very, very important to us. And when we play around with different digital modes, right now we're in the frequency response mode. We'll get over to let's say time coherence mode. You'll see very distinct but very slight differences.
Yeah, we need to reset. We will show the new result. We will average out, then we see that.
So you
Yeah,
can
the
see
pattern
that it's
changed.
different. The pattern has changed, but you can even see that perfect fifth is just kind of peeking out there a little bit more, right? So those little intervals are super important, and it's the kind of stuff that both Larry and I listen for, and we have different tastes in the music that or what we want the system to sound like, and we listen to very different music. So so that's all of those digital modes. That's what we're focused on right there. Yeah.
Good.
So
Thank you
anything
for
else?
your
Yeah.
support, Signature Edition backers. We love you.
Yeah, thanks guys.
And
Thanks,
when,
guys.
when are they going to be available again for purchase?
Oh, let's see. Did we say the 27th? We have 12 that we can sell, 2 of which belong to us. so we'll make 10 available next week. I think that's Monday, right? The 27th.
Yeah, there should be the only one batch because it really costs a lot of time. But I really don't want to make them. Let's get it done. All right. Thank you.
Thanks guys.
Thanks.